Uh, okay, today we are going to look at this question. This is from 2012 May June version 23, question number 2. Uh, if you haven't read the question, you can pause the video and look at it. We are not going to do A part or B part, you can do that in your own. We're just going to discuss a doubt in the C part. Okay, alright. Okay, now what is happening here is that the log is being accelerated using a cable, and during its journey from the point S till it reaches a particular point along the inclined plane called P, it is connected to a cable, and that cable is connected to a motor and it is being accelerated. Okay, so in the earlier part of the questions you will be calculating what is the tension and everything. So we have calculated that the component of weight along the inclined plane is 1070 Newton, and the tension in the string is 1650 Newton, and there is a constant frictional force that is up between the surface and the log that is equal to 525 Newton. Okay, so in the beginning what happens is, as a resultant of these forces, the log is accelerating with an acceleration of 0.13 meters per second square. So till it reaches the point P, till the cable breaks, there is no difficulty in drawing the velocity time graph. It is going to be acceleration with a constant acceleration of 0.13, so a straight line through origin. Okay, remember at this point it will have a gradient, because when we start the time at S, it has an acceleration 0.13, so it will have a gradient, and the graph will not start like this with zero gradient at the beginning. It will have a gradient right from the very beginning. Then the cable snaps at P. Now when the cable snaps, you have to look at what is happening to the forces. What happens is that this tension is no longer present, and there will be the downward component of weight, and frictional force will be there. Now when the cable snaps, the log has a velocity of 1.6 meters per second. So for a little while it will continue to move upward, and because it is continuing to move upward, the frictional force will also act downward. So even after the cable snaps, for a time being there will be a downward weight component and a downward frictional force. So altogether the log will be moving with the downward resultant force of 1070 plus 525 Newton, that is equal to 1070 plus 525, 1595 Newton. Now the weight of the block, the mass of the block is 452, so 4 divided by 452 is 3.5 meters per second, so 3.53 meters. So this will give you an acceleration, a deceleration value of 3.53 ms minus 2 downward the plane. So now we have to understand that this angle corresponds to 0.13 meters per second square. This is 3.53. That means compared to this angle, the deceleration will be steeper. Hence you will have a very steep deceleration, and when the log reaches its maximum point, just like a ball thrown upward, and there is no necessity that the maximum point should correspond with the motor, okay, just somewhere above P. So when the log reaches the maximum point, the velocity becomes 0. After that, what happens is the log will have a downward force of the component of the weight 1770 Newton, but just a small change will happen. The friction will start acting upward, because now the log will try to move downward, hence the frictional force will act upward, right? So you will have a frictional force of 525 Newton upward. So the resultant of these forces would be 1070 minus 525, that would be 545 divided by the mass of the log, that is 452. That gives you 1.21 meters per second square. 1.21. So this resultant force will give you an acceleration now that is equal to 1.21 meters per second square. Okay, so what will happen is, so this angle corresponds to 3.53. Now we have 1.21. So that following line should be less steeper than this. At the same time, it should be more steeper than the first stage, because the first stage corresponds to 0.13. So we will have in between steepness, and the velocity will continue to increase in the negative direction. So negative direction in the sense, earlier it was moving upward, so that velocity is considered positive. Now it is moving downward, so it is considered negative. And compared to the maximum velocity in the stage 1, the final velocity here will be greater. Why? Now this area here and the area that's going to be here should be equal, because both the areas are equal to S2, that maximum height. So this area here corresponds to the S2 maximum height, and this area here corresponds from the maximum height to S. So both of those areas should be equal. Now this velocity was reached with 0.13 meters per second square, so it took a long time. Now this acceleration is going to be going to be greater than that, so it would take comparatively less time. So when the base is smaller, then obviously the height should be greater for that to be for those two areas to be equal. And compared to this one, 0.13, this is 1.2, that's like 10 times. So it should be very, very large, not just like this, it should be very large. But since we have drawn it like this, so actually if you want to properly draw it, it should be like this. So we have a very small acceleration in the beginning, then a sudden drop, then something in between, and that in between obviously will have more, like actually it will have about 10 or 9 times the final velocity. Okay, because compared to this base, this time is going to be less, hence it will have a greater height. Okay, so if you look at the mark scheme, so those are the points which are considered. So the straight line from origin, line down to zero velocity in short time compared to stage 1, line less steep, negative gradient, final velocity larger than the final velocity in the first part. Okay, then how people have done it in the real exam. So the two later stages should have shown the log slowing to zero velocity. The majority of the candidates were unable to interpret and then draw these two stages. So not only few, but a lot of people found it difficult to draw the last two parts.